Okay, so I'm going to talk about the carbonyl group today. Specifically, I'm going to talk about naming ketones. So ketones have a particular functional group called the carbonyl group, sometimes called the carbonyl group. I always say carbonyl. It's a carbon atom double bonded to an oxygen atom. It's polar. And if you look, so it's the carbon. We're just talking about the carbon to the oxygen. The carbonyl is just that. The carbon can be attached to hydrogens or carbons or whatever over here. This is still called the carbonyl group. Now, we see the carbonyl group in two types of compounds. We see it in aldehydes and ketones. So I've already talked about aldehydes, or I talked about aldehydes in a separate lecture. I'm talking about ketones now. So a ketone is specifically an organic compound with the carbonyl group, but the carbonyl carbon is bonded to two other carbon atoms. So there's no hydrogens attached to the carbonyl carbon at all. It's attached to only two other carbons. Now, these carbons can be attached to, these could be terminal or attached to whatever else over here, but the carbonyl carbon has two carbons on either side of it. So that makes the simplest possible ketone this. This is actually, its common name is acetone. We'll learn the IUPAC name shortly. So the way to name a ketone, this is going to follow pretty much all the other sorts of naming that we've seen before, the same basic pattern. So we're going to always find the longest parent chain. So let's say I've got a carbon, carbon, carbon. Right? So I'm going to number, and I'm going to number closest to the end, the end closest to the carbonyl group. So let's also put a substituent on here just for fun. So I'm going to number closest to the left end here. 1, 2, 3, 4, 5, 6. So I have my carbon, my methyl group here. So this will be 5-methyl. Now, I have to indicate where the carbonyl group is. We know the carbonyl group is not going to be at 1 or 6, but it is going to be it could be on 2, 3, 4, well, not 5 in this case, but we have to indicate when we write the name where the carbon, just like with a hydroxyl group, we have to say where their carbonyl is. So for a ketone, unlike an aldehyde, I do have to put a number. So I'm going to put 3, and then I'm going to say hexan to indicate how many carbons are in the parent chain. Hexanone. The ending -one indicates a ketone. So, and that's basically all there is to it. And then say any substituents. So as like other functional groups, what am I trying to say? The parent chain must include the carbonyl carbon, and so we do have to give it the lowest possible number. So let's just practice this. I think this would be the easiest way to do it. So here's some practice. Go ahead and try these, and we'll name these. Pause them and give them a try, and then I'll help you out with this. So this first one, here's our longest chain. Now, we can either start numbering from the left side or the right side. Actually, I'll use the mouse here. The left side or the right side. Notice if we go from the left side, the carbonyl becomes 1, 2, 3, 4. If we go from the right side, the carbonyl is 1, 2, 3. So we have to go from the right side. So 1, 2, 3, 4, 5, 6. So the parent chain is going to be hexanone. It'll be 3 hexanones specifically, and then it's going to be, the substituents will be 2, 3, 4 trimethyl. I'm writing this very poorly. 2, 3, 4 trimethyl 3 hexanone. So that's the 2,3,4 trimethylhexanone. Oh, 2,3,4 trimethylhexanone, 3 indicating where the carbonyl group is. Okay, this one Here's my longest chain. We want to start numbering from the right side. 1, 2, 3, 3, 4. So 1, 1, dichloro, 2, I have to continue down here, unfortunately, butanone. So 1, 1, dichloro, 2, butanone. Over here, it's pretty clear we're going to number from the right-hand side. So 1, 2, 3, 4, 6, 7, 8. So 2 octanone. There are no substituents on this one. There's just a straight chain. There's just a kink in it from the way it's drawn. Okay. Try drawing these, and then I'll go through these. So 3 pentanone means I've got 1, 2, 3, 4, 5, and the carbonyl is at carbon 3, and the methyl group is here. 2,2-dimethyl-4-octanone means I've got 8, 1, 2, 3, 4, carbonyl number 4, 5, 6, 7, 8, and 2 methyls at carbon 2 methyl groups at carbon 2. Then we get bromopropanone. So this is kind of funny. There's no number here indicating where the double bond is. Well, let's look. Propanone is 3 carbons long. Well, and there's not even a number saying where bromo is, where the bromine group is. So let's take a look at this. Often if the numbers aren't there, it's either incorrect or they're unnecessary. So let's take a look. If it becomes unclear, then this is incorrect. But if it's, we only have one option, then it's just the numbers were unnecessary. So either way I go, if I have 3 possible carbons here, and the issue is, if I put the carbonyl here, this is actually no longer a ketone. So this is not propanone. Same thing with putting it on the last carbon over here. I have to put it, in order for it to actually be a ketone, a propanone, there is only one option for propanone. So propanone is the smallest ketone, and it's the only one we don't have to indicate the number on, because any bigger and you have to say whether, actually, now that I think about it, butanone also, just a little aside here, butanone, it's going to be on number 2, and if I were to put it on the other one, then that would become carbon 2. So I may have spoken erroneously in class now that I think about it. So I guess pentanone is the smallest one that actually needs a number. Smallest one that needs a number. So propanone here has the carbonyl here, and then bromopropanone, I've got 1 bromine. I could put it here, or I could put it on the other one, and again we hit that same situation. If I put it over here on the right-hand side, then I would just end up numbering number 1 here. So whichever bromine, or whichever carbon I put the bromine on, becomes carbon number 1. So this one just simply doesn't really need any numbers. So bromopropanone is fine. Now, 1,1-dibromopropanone, why do we need the numbers here when we didn't up here? Let's take a look. Well, propanone, we've already established, doesn't need a number for the carbonyl group because it must be there. But if I put 1 bromine here, well, that's carbon number 1. But it's possible, actually, I should have noted that in both cases, the bromines can't go in carbon number 2 because it's got all of its bonds already. But I could have 1,3-bromopropanone if I wanted. So this is particularly 1,1-bromopropanone. And then 3-hexanone, our last one here, is fairly straightforward. In that, it's just hexanone. 1, 2, 3, 4, 5, 6. And then carbon number 3. Oh. Carbon number 3 right there. So there it is. Hope that helps with naming.